Very good morning, everyone. I welcome you all for the 10th session of this ATAL Academy sponsored 1 week faculty development program on Internet of Things, enhancing smart IoT applications using advanced processors. I would like to take this opportunity to introduce the resource person for the session, Dr. P.S. Godwin Anand sir, Head Research and Training, Omega Engineering Systems and Solutions, Kanyakumari, India. Dr. P.S. Godwin Anand sir received his Bachelor of Engineering in Instrumentation and Control Engineering from Madurai Kamaraj University, Tamilnadu, and Master of Engineering in Process Control and Instrumentation from Annamalai University, Tamil Nadu. He received his PhD in Electrical and Electronics Engineering from Anna University, Chennai, India. He was professor and head of the Department of Interdisciplinary Engineering, St. Kitts College of Engineering, Kottayam, Kerala, India, for more than a decade, and served as a principal at Cochin Institute of Science and Technology, Kerala, India. He has received research grants in the field of robotics and automation from the Government of Kerala and ASAT. Presently, he is the head and research and training at Omega Engineering Systems and Solutions at Nagapur City, Tamil Nadu. He has more than 2 decades of teaching and research experience. His area of research includes artificial intelligence, control theory, robotics and automation, and advanced optimization techniques. He has more than 30 publications in reputed journals and acted as a key resource person for numerous faculty development programs. He has been as organizing chair for various international conferences, which includes IEEE, AICT funded conferences. He is also an active member of IEEE, ISA, and ISTE. In this moment, I welcome Dr. P.S. Godwin Anand sir to deliver his expert lecture in the field of IoT in this session. Welcome you, sir. Thank you.
Thank you. So good morning, all of you. Today, I'm going to give a lecture on evolving of IoT in the industrial sphere. That we call it as IIoT, or we call it as Industrial 4.0. And this is IoT has given a wide spectrum in today's application due to the advancement of internet technology, and we are using day-to-day life that IoT technology, and this IoT technology has been evolved to the industrial domain that we are going to see in this lecture. So today I'm going to discuss about that slight overview of IoT and some concept behind IIoT. These things that security issues, application levels, the topology, architecture, these things we are going to discuss in this lecture. So here, if you see Internet of Things, there are numerous definitions available in Internet. We don't know which one is correct, or so I have quoted the which is the context is suitable for IIoT. So this IoT is defined as embedding the phenomena of ambient intelligence for devices to measure, monitor, and master the physical world with cloud-based processes. Is defined as IoT. So anything, if you see, it needs to measure, then it has to be monitored or processed, then monitored, then processed, then it is to be monitored. So that is the basic fundamentals of any system. In today's world, the industry leaders and tech experts are embracing all potential IoT opportunities with organizations on a priority basis. There is a compelling drift on focus of visibility, operational efficiency, and productivity to fueling the innovation in hybrid business model. So there is so when we incorporate all this recent technology in our business or in our industry or in our day-to-day life, this can be our efforts will be less complicated, and the productivity of our any application is going to increase. So that the thing what we are going to discuss here is the challenges and the benefits. If you see the progress of IoT, so before 2005, each applications are centralized, close centralized. That is, for example, if you want to book a flight, we have to go to the particular site. For example, if you want to book a flight for Indigo, then we have to go only through Indigo website. During the late 2005, before that and all. So after that, that is the cloud-based computing technology has evolved during 2000. At the time, that came into application after 2002, 2005, this time. So these devices have the operation, or it can able to access or process with the cloud process. So that is the open access IoT network, and the cloud is centralized there. So any application, if you see, a single website can do all the application, like even hotel booking, train booking, or whatsoever it is. So that is that. And again, it has to be a single cloud which communicate to each and every device. And the future of IoT is the cloud, the device can able to communicate with multiple cloud servers, so that each device can communicate with each other. So that is not happening right now. The device, the device is allowed connecting to the cloud directly. So in future, the device can be connected with among the device itself. That is the progress of IoT. There are some application which is currently existing in today's application. So IoT, if you see smart homes, everybody is using, most of the people now using like smart bulbs, any ovens, refrigerators, coffee vending machines, etc. So for example, if you take a fridge, the fridge performance is monitored by the seller, not seller, the manufacturer, because if there is any troubleshoot, that it is can be directly connected to Wi-Fi. That is smart fridge. So these applications are basically smart homes we are using for our home applications. And next one, security systems. During this last decade, you can see the number of surveillance cameras has been deployed in various areas, including our homes as well as in the streets. So all these cameras are connected to the cloud, and based on that, we can able to do the security, smart security purposes, and digital locks or security locks. So anybody breach the lock, immediately we'll get the alarm system that kind of applications are there. That is what we are seeing is the current applications we are using. Real-time tracking tools like, with the share market prediction. There's that is when you book a cab, we can able to track that Ola or Uber car, where it is coming, or any delivery guy, where it is coming, that kind of tracking. Other than that, we can able to predict the company any object performance lively. That is that real-time tracking tools are available. In previous cases, we get the set of data and then do the analytics. Now here we'll see the online analytics which is happening in the real-time tracking. Monitoring system is also similar like security systems. This kind of monitoring systems are used in intelligence department, police department. They monitor. A person cannot monitor all the camera deployed in front of him, all the display showing in front of him. So what is happening is there is artificial intelligence is incorporated in the system itself to any abnormal condition or overspeeding or any threat comes, immediately the machine learning system immediately report it and give a alarm system to the operator, so that he can able to have a key on it, so that this can able to be noticed at the instant itself. So when this systems is not there, it is very difficult to monitor hundreds of camera which is displayed on the front screen. So IoT helps adding intelligence into the monitoring system, so that it can able to detect any malicious functions which is happening or unauthorized happenings in the surveillance system. Smart gloves. Smart gloves is one of the things which is using in packing, transportation, everything. So when we pick an object from a particular rack or thing, there is a barcode which is attached to that glove, so that what object he is picking is immediately transferred to the manufacturing sector or transportation system, so that he can able to, so that the system can able to take a note of it, and it can able to do the statistics for that, and it can able to say how much package has remaining, how much is sold or how much is transported, etc. Smart mirrors we have seen in Facebook or something like that, YouTube, and it is also there. When there are in foreign countries, they have used these smart mirrors. When we put a dress, how it suits for us, of the fitness, size, everything. It can able to say which color or which size or how we look when we wear these kind of things. And other than that, also the mirror can able to engage with us our day-to-day life activities. It can synchronize with the calendar system, or what is the date, what is the schedule, etc. And the last one, these are the most commonly we are using. The last one, most of them we are using. The smartphone is one of the thing, and other than that, smart watches, smart bio equipments like smart glucometer, smart pressure monitor, heartbeat monitor, spectacles, etc. These can be used as a wearable smart devices, which will give the information from our source, and it processes the information and what is required for us. So now we come into that, what is industrial Internet of Things? The industrial Internet of Things, that they call it as IIoT or Industry 4.0, refers to the interconnected sensors, instruments, and other devices networked together with computers, industrial applications, including manufacturing and energy management systems, and much more. The connectivity allows for data collection, exchange, and analysis, potentially facilitating improvements in productivity and efficiency as well as the economic growth. When a company, every company is looking for the growth. The growth is depending upon the production and manufacturing and the efficiency of the company. That is done based on the industrial Internet of Things. We are not, the industry is not only doing a particular application using IoT. If you are moving to the IoT platform, the total structure from the floor to the top level, it is connected with IoT thing. So that is the main advantage of the IoT. So here, in any industry will consist of sensors, instruments, and devices, and these are interconnected with each other. The history of IoT. Actually, we are talking about IoT in the past few years. That is maybe from 2005 onwards. But actually, in industry, they have begun the 1968 itself, based on a programmable logical controller. That is, Dick Morley was invented this PLC. We call it as a programmable logical controller, which was first used by General Motors for automating the manufacturing division. That is, transmission manufacturing division. So PLC is one of the first automated controller which is used by the manufacturing industry to automate their production. So this PLC previously itself communicating with this, first it was used in standalone, then it is communicated with each other. So we are not calling the name called as IoT or IIoT, but it was happened during 1968. After that, 1975, Honeywell and Yakakova introduced the world first DCS. DCS is nothing but a distributed control system. Distributed control system, the next step in allowing the flexible process control through a plant with backup redundancy. Backup redundancy means if you take a server, or if you take a cloud server, what server it is, we need a backup redundancy. So similarly, in industry, the same thing is happening. When a controller fails, there is a redundant controller. There will be number of DCS there. That DCS will communicate one DCS to other, and this communication will have standard protocol. That protocol, at the time, they are not taken to the internet, but that protocol they have used inside the factory itself. The IIoT is an evolution of distributed control system that allows a higher degree of automation by using cloud computing to refine and optimize the process controls. That means this IIoT and DCS add intelligence into the control system and automation process. Previously, we do some control algorithm. That control algorithm will do a standalone control operation which doesn't have any intelligence. Based on the model, it will work. But in IoT, we are adding intelligence, that is using by the help of deep learning, machine learning, etc. We are using that process, that is artificial intelligence, to the control or manufacturing purposes. So there is a slight difference between IoT and IoT. In our world, things are different. in Internet of Things, things are toasters, coffee pots, and refrigerators. That we mainly deal with IoT. If you say IoT, all devices are interconnected or are connected through a cloud. That what we are connecting? We are connecting toasters, coffee pots, refrigerators, air conditioning, televisions, etc. In the industrial Internet of Things, that are machines, IOs, controllers that makes these devices. That we call it simply put in quotes, that is a manufacturing industry. The manufacturing industry, toasters manufacturing industry, coffee pots manufacturing industry, refrigerator, car, automobile, etc. So that is the difference between the thing. IoT deals with industry things which are devices, and IoT deals with the things which are making the devices. So the industrial Internet of Things, we'll talk about the world, the industrial world. IoT is for consumers and IIoT for engineers and factories. IoT is for consumers and IIoT for engineers. Although both built in a connected things are different, but one be a subset of other. Actually, one be a subset. IIoT evolved from IoT. So we are clubbing some of the things like cloud, data transmission, this kind. We are taking the concept from IoT, but the devices are entirely different. IoT needs some standards. IIoT has a defined standards. That is the main communication protocols, field protocols, which are used to communicate within the devices or within the machines. That is a major difference between IoT and IIoT. But it has Profinet and OPC standards that we'll see. So if you see the comparison, IoT is a revolution, and IoT is an evolution from revolution. IoT is a thing, that is things, we call it as a fridge, refrigerator, air conditioner, toasters, coffee vendors, and IoT is data. Data is whatever data, it's a field data or a prediction data or a consumer data, etc. IoT, if you see the ad hoc connectivity, most of the IoT devices are ad hoc. Ad hoc means from the cloud, from the cloud, we can able to communicate the particular device. My device cannot communicate with the other, my air condition cannot communicate with the other air condition. So that we call it as here ad hoc connectivity. In IoT, the connections are structured connectivity. This is, if you see the concerns, it is important. We have to say the concerns are important, but it is not very critical as like in IIoT. So IIoT is very critical, that we'll see later. That is, we have to look into analytics, security, data integrity, response time. So IoT is user served. So there are millions of IoT applications by a third party or any party, so that they can able to download that application and use our mobile phone. Or if you go to Play Stores, you can see number of applications. That is user service. But IoT is vendor service. Vendor service is that is user plus OEM. OEM is a original equipment manufacturer. Vendor service, vendor served. That is IoT is new. That is device and standards are new. That is we can find the new standards for new application. But for IoT, the standards are existing. That is devices and standards are very existing. We cannot able to bypass that standards. If you bypass the standards, that definitely we cannot say that is IIoT. So this week say about that major difference between this IoT and IIoT. So this total defined structure can be defined in three classes, that is data access, uptime, and openness. Openness is open standard. So multiple vendors can integrate the product with the existing IoT if it is compatible. So if you see the IoT and IIoT, there are some common things what I said earlier. IoT, most of the time we are talking about household usage for the commercial sector. IoT is for industrial sector, and both the things which are common is data management, connectivity, data security, and secure cloud. These are the common thing which IoT and IIoT shares the thing. So in this way, this IIoT evolved in a different domain by only taking these particular concepts or particular services from IoT. But the applications are entirely different. There are 4 key areas of IoT. And then if you see that there are 4 steps. The first one, the smart system control. The smart system control that is already existing. That we saw that during 1975 DCS, evolvement of DCS. At the time itself, this smart system control is there. That mainly any smart system, when we incorporate that, will give the increased competitiveness, that is improved product quality, advanced diagnosis, flexible and predictive real-time control, vertical and horizontal integration. Vertical integration means going to the next level. Horizontal integration, developing the more number of devices, that is call it as a vertical growth and horizontal integration. Standardization and interoperability. So already we need some standards that is already existing. That is in the first area, that is smart system control. Now that is under domain, that is smart operation, that is asset optimization, reduce operating expenses, predictive maintenance, OEE, KPI visualization, and OEE, that is overall equipment effectiveness, and the KPIs, key performance indicator visualization. That is not there in the first, that is the past one. Now we are integrating that OE and KPI visualization, that is system of system integration. That is we are adding some more system which is making the things smarter. We can add some more devices to a existing device, that we call it a system on system integration. And now we are going to optimize asset optimization. The next one is smart things. So it is in the pipeline. So that is our most attractive product with services. So what is in the consumer need? Based on that, we will able to develop our applications, or we develop our services. So when a person is buying, first, how the mobile phone is there? The mobile phone is meant only for making calls. After that, mobile phones are meant for only making calls. Then SMS. Then it came smartphone, which can able to use some other application. Then it came for camera, then apps. Then now if you have a mobile phone, we don't need a computer to do all kind of stuffs which we are on older days we are using. So buy-based end user data insight, remote access for online support. Remote access for online support. So when a system is, we want to troubleshoot a system, there is no need for an engineer or an expert to come to the field and do the maintenance work. He can able to do the maintenance, or he can able to troubleshoot the controller or the device from his location itself. That is, he is situated in either in US or Canada, somewhere else, but our factory is located here. He can able to calibrate, or he can able to do the remote access for online support. The industry 4.0, that is creating future standards, highly efficient, integrated or dynamic manufacturing with suppliers and customers throughout the value chain. So this is the thing which we are going to see. So gains from IoT, that is both the internal benefits and the external benefit. First, safety and security, reduce expenses, conserve resources, optimize assets. That is the internal benefit. And the external benefit is increase engagements, generate revenue, improve well-beings, enhance services, and the collective maintenance is collective benefits are productive maintenance, remote diagnosis, real-time monitoring, and asset resource optimization. These are the gains which we are getting from IoT. If you go adapt this industry 4.0 standards, these are the benefits we are going to. These are the minimum benefits we can able to achieve. So if you see any protocol or any architecture that should contain some standards, that is layer type. Here we are seeing that are 4 layer type. That will come from the bottom line, that is device. The device has to be networked. Then there is service that is application, and that is analyzed. Then content is the display. First acquire through the device, then transport the device data, then service, then display. So devices we say as CPS. CPS nothing but a cyber physical system. It is a computer system which is a mechanism controlled or monitored by a computer-based algorithm. That we call it as a CPS. Then machines, we know all what is machine. Sensors, actually there are various numerous sensors of that. If you see in industrial type sensors, we will see level sensor, flow sensor, temperature sensor, pH sensor, etc., etc., etc. And communication protocols, we are using 2 communication protocols, that is Profinet and OPC UA, that we'll discuss. And Wi-Fi and the communication protocols, Wi-Fi, that is a communication type, Wi-Fi type, and the server, cloud server, and computing, we call it as cloud computing is also there. Edge computing is also there. So as far as the major difference in IoT and IIoT, IoT cloud computing is taking place, in IIoT edge computing is taking place. The difference we'll see. Services like application software to analyze data, transform into information. So simply we cannot give data to the user to display. So we must use some meaningful data, that is a report format or a consolidated format. So for example, the average, when you're driving a car, that average speed we are going. The speedometer shows the current speed, but current speed will be always fluctuating. But we want the average speed. So that for calculating the average, there is a application is there. There is some formula behind that. Similarly, there are numerous data available there. the performance of the process or etc. That has to be analyzed, and the data has to be and the data has to be incorporated into it. The user interface devices are like, the touch screens, tablets, smart glass. So that is we have seen in that earlier slides. So in the screen, just it is visualizing that either it can be a touch type or any type of application it can be. One second. So this is the thing I have. IoT system usually connected as a layer module type. The device layer refers to physical components. CPS and then our sensors or machines. The network layer consists of physical network, buses, and cloud computing. This communication protocol, which I said earlier, that I have. This is written, so we can direct. So if you see the architecture, there is that the edge, the network, the cloud, and the application. The previous, that is a presentation or the edge layer is the important thing in IIoT. This we call it as the edge layer. That is here if you see real-time control, there are pumps, valves, HMI. HMI is nothing but human machine interface. These areas are located in the plants. And these are wired through connected to the wire, and from the gateway it is connected through internet. These are connected via wireless, that is Wi-Fi, that is IEEE standards Wi-Fi. And this computing plus storage, here this cloud computing is taking place. We are not mentioning the buses involved in it. We'll see the buses in the next coming slides. And here application analyze, reporting, planning, optimization, engineering, HMI. So this is the normal architecture of IIoT, in which we can able to incorporate in any industrial sector or manufacturing sector. So I told you that edge computing is quite different between other. It's a distributed computing paradigm which brings computer data storage closer to the location where it is needed. In contrast to the cloud computing, edge computing refers to decentralized data processing at the edge of the network. So why this is very important means, when we do real-time control applications, we cannot completely rely on cloud, because the cloud is located somewhere in US, or we don't know where it is located, cloud server. So when we allow this data to go to cloud and process back to the field, it takes more time. So we cannot wait until that. Our machining operations cannot wait. If there is any jitter or if there is any communication lag, that will affect the product quality and it will destabilize the control performances. For example, speed control, velocity control, or this kind of things, it is very crucial. Or image-based processing, image-based manufacturing processing, like the robotic actions. That kind of systems can be done based on edge computing, which is this computing is done inside the machine, near to the machine itself. But this the industrial internet requires more than edge plus cloud architecture, rather one plus purely centralized cloud. That's what I mentioned. The industrial internet requires more of an edge plus cloud or another one is purely centralized cloud. In order to transform productive products and services in the industrial world. So well, let's see. I told there are two standards. One is Profinet and another one is OPC UA. Profinet is the abbreviation of Process Field Network. Profinet is nothing but Process Field Network, and it was introduced during 2003. It was introduced during 2003. Before that, there are Profi buses are there, field buses are there, CAN buses, ISI 95, there are many buses are there for as per industrial standard. After the evolving all kind of buses, Profinet comes into the application during 2003. It is foundational to the industrial Internet of Things, which lies on overlap of industrial IoT and the Industry 4.0. The difference between IoT has evolved over the years. It is not developed just before that and just come into market. It was the Profinet was evolved since that is from 1975. From that, it has taken to a shape called Profinet. Profinet is all about data getting the need and intervals which indicates quality industrial architecture without changing the topology. So the main thing is all of the devices are manufactured and the communication will work for some standard topologies. That topology is we are not going to change. So in the topology, it will fit into the Profinet can fit into it. Only Profinet provides the speed required for any application from microsecond for high-speed I/O and motion to milliseconds for discrete IOs. See, that's what when we put into cloud, we cannot able to have millisecond or microsecond closed loop performances. So that's why Profinet provides a vital role in industry IoT. OPC UA that was discovered in 2008, come into application, 2006, but it came into application in 2008. OPC UA is open platform communication unified architecture that is called as OPC UA. It is a standard for horizontal communication from the machine to machine and for vertical communication all the way to the cloud. So it can able to communicate M2M as well as it can able to communicate M to cloud, machine to cloud and machine to M, that is vertical and horizontal communication. It is vendor and platform independent, supports security mechanism and can be optimally combined with Profinet in a shared industrial Ethernet network. OPC UA can also be integrated into an existing industrial Ethernet network and run the existing Profinet infrastructure without compromising the performances. That is the main thing. So any industry 4.0 must use Profinet and OPC UA. Profinet cannot transform data to the cloud. OPC UA will transform the data from machine to cloud, and it can otherwise also it can able to communicate from machine to machine. That is the advantages of OPC UA. So why Profinet and OPC UA? Many will have a confusion that is the heart of the question about OPC UA is it is automation protocol, it is a SCADA protocol, or it can exchange real-time data information Will it replace Profinet, Ethernet, or EtherCAT, or any other internet-based automation protocol? The answer is to each of these questions is maybe, but in some cases not likely. The better answer, let us look at what Profinet and OPC UA will do. Then we can able to come to the conclusion why and when and for what Profi and OPC UA. So if you see that comparison performance, cycle time typically between Profinet 0.125 millisecond to 512 milliseconds. OPC UA approximately 200 milliseconds depending upon the server capabilities. We cannot have a dedicated cloud server or this because when we have a dedicated cloud server, we cannot able to communicate with the IIoT, that is other server cannot able to communicate with that. Then we call it as a standalone cloud. So this is typically the response time is 0.125 milliseconds and it is 200. That is far difference. If you see the jitter, you know that that is breaking of data or some noises in the data. That is 0.001 millisecond. That is here also it is around 100 milliseconds, 10 to 100 milliseconds. Data format, tightly defined data format with only few types of structures. That is because it is only communicating with machine to machine. That's why the data types are defined and the format is a minimum type format. And OPC object-oriented data from which the flexibility match follow all type of data. It can able to take any number of data from a machine and it can able to transfer to the cloud. Network boundaries, Profinet is not forwarded by routers and cannot cross between networks. That is the limitation in the Profinet because we cannot have a compromise between speed of response and communication. That is, we have to draw a line. If you want, we must have a trade-off. If you want speed, then at speed of operation, then we can go, we have to use Profinet. And again, the limitation is we cannot able to bypass any routers. So in the field level itself, Profinet application will be over. OPC UA is a router protocol and can used to be even over the internet. Cycling data exchange, it's a guaranteed performances. That is, cyclic data exchange is the continuous data exchange. It is a guaranteed performances. Since Profinet came into application not by just into market, it was evolved from over a period of time. And best effort performances is it will give the best performances based on this limitations. Performance that is looking into the data. OPC doesn't make a grade for true real-time control protocol. So why we call it as true real-time control? If you use IoT or if you use IoT or if you want to switch on or off a AC, it can be delayed by 10 milliseconds or it can be delayed by 1 second. That is not going to have that is not going to make a much devastation, or it doesn't affect any serious issues. But if you take a motion controller, the motion controller is based on that the tool is moving in a particular speed. In the time 10 milliseconds or 1 second is delayed, definitely the product quality is affected. So that looking at the data, OPC does not make a grade for a true real-time control protocol. So it can able to transfer, and communication can be a very good communication protocol, but it is not a control protocol. It is just too slow to implement control loops for most motion applications. So while you may see the OPC appears in the datasheet for IO devices, alongside Profinet, the features that fills a distinctly different role. So OPC UA is a greater for moving information to higher level system, but Profinet forms a backbone for distributed IO control. So what we can do is combine Profinet in the field level, and from the field level, we have to take the data to the cloud. So OPC UA takes care of that, and Profinet looks into the field control. In that way, integrating these two, so that we can, the communication as well as the control performances will be much more effective. See the architecture of OPC UA and Profinet. This is the field level. This is a field level. This field level has various devices like conveyors, robotic arm, then motors, pumps, edge computing devices, and this other PLCs or distributor controllers. And this is the controller, other controller, main master controller. So this can be communicated, or this can be a network with Profinet, handles data action between the machines. So this data already goes to this controller. From this controller, OPC servers. This server will transfer the data to SCADA, MES, or any other clouds and clients. So in this way, it is working. So the speed of the control action is compromised. The speed of the control action is not compromised when we use Profinet. So again, we must share the data to the cloud so that OPC UA handles, or it looks that work in a fine manner. The same thing, how it is done. This is a Profinet, which is given, and the OPC UA, that because Profinet doesn't need any security because it is used in the field itself. So OPC UA, when we go to the, when we pass the data to the cloud or the communication is taking place with the other servers, we must look into the security aspect also. That we will see in the forthcoming slides. Here, SIOME is nothing but Siemens OEM UA, OPC UA. This is see OPC UA interaction with the Profinet and field level, control level. So this is the main concept which is different from the first one, sorry, IoT and the IIoT. That is cloud. If you strength of OPC, if you see the strength of OPC, this is platform independent, direct device integration on all levels, authentication, encryption, semantic services. These are the benefits of OPC UA. And if you see the Profinet, it is determining real-time capability, M2M communication in real-time, standard profile. Standard profile means when we use in industrial control, there are for controlling motor, there will be some algorithms. There are various algorithms, standard algorithms that are inbuilt in the Profinet standards. So how the communication links takes place? Vertical and easy machine integration. So OPC UA takes the communication to the next level. Previously, there is no OPC UA. After 2008, only IIoT, that is all industry level activities are coming into cloud-based activity. So here, if you see, these are the two devices. This is displays, and this is also display. Sorry, this is a controller. What it does is, here that is it. Green color is a Profinet line, and the blue line is the OPC UA. So here, if you want to have an additional device, then what we are doing is just put a device and integrating it, and this is compatible with Profinet as well as all this. This is compatible with Profinet as well as OPC UA. So there is a communication bridge, so it will able to communicate this. So here again, the similar easy integration of the third-party system. This is the third-party system. This is the third-party system. This is the HMI is the default system which we have. WinCC is nothing but a SCADA application. Semantic is also a SCADA application, so that this can able to monitor the performance with the third-party application. So that is mainly because of OPC UA. With the help of OPC UA only, we can able to do it. If you see the factory automation level, see all the power supply, industrial identification, IOs, device drive technology, industrial controls, these things are only Profinet level. This can able to communicate when it is falls in between these two. This can either be at the communicate through from cloud as well as OPC and Profinet also. These things only uses OPC UA, that is SCADA automation designer. That is when we have to design some piping and instrumentation diagram that we can able to design in the automation designer. Management operations, energy management. So these things, this is the segregation level for so the total we call it as industrial Ethernet. So this is some of the differences which we have done earlier, but some more additional points of that. Area focus, IoT, we deals with commercial consumer conveniences. So it is mainly for consumer conveniences we are using IoT. IIoT monitoring and managing system for high-stake industries, defense, manufacturing, healthcare, etc. Focus development, smart devices. When we are focused on development, IoT focus only on smart devices, and IIoT we focus on sophisticated machines. Degree of application, active sensor, advanced controls and analytics, simple application with low risk impacts. Then security and risk measures. This is utility centric, and if you see the security and risk measures, and it should overcome the security. That is, we have a high redundant and low risk. That is the advance of this. This is advanced, and it should be very robust to overcome the security issues and the risk management. Interoperability, that is again, it is functional independent. And interoperation, here it is integrated with coexisting. That is, it has to integrated with the existing devices. Scalability, that is low scale network, and again it is a large sector, then we call it as a large scale network. Precision and accuracy, and critically monitored. When you say accuracy and precision, it is critically monitored. We don't want a 0.01% accuracy or this much percentage accuracy. or we are not. In IoT devices, we don't say like that. But in IoT, it has to be synchronized 2 milliseconds. And some application, even microseconds is also there. Programmability, easy offsite programming. So here, remote on-site programming. That is easy offsite programming, yes. Also, nobody need to come into the site. So everybody can program there because it is done through the cloud. And here, remote on-site programming requires support new process to require to support a new process. So when we are integrating a new process, that has to be configured, and some program has to be done. That with the help of OPC UA, someone can from remotely able to do the operations or do the programming and the configurations. So output, definitely IoT for convenience purposes, we are using IoT. And for economic growth, we are using IIoT. Lessons, we don't have a high lesson on IoT, but in IIoT, it must be automated to support fault tolerance. For example, if you see, if you are wearing a smartwatch, if it fails, it doesn't, only thing is we are not going to see the time, or we are not going to see the heartbeat, or we are not going to attend the call. That is not going to bring a serious impact. But if you see in industry, when a controller fails, it leads to a disaster. So it leads to a disaster. So the machine won't work. If the process is very hazardous, definitely it leads to explosion. So that it must be automated to support fault tolerance. Any fault occurs, definitely a redundant controller has to be come into action. And if you see the maintenance, consumer preferred, that is, if I want to do any maintenance, if I like, I want to do any reboot or reset my watches if it is doing very slow. That is again my wish to do my system. For example, if I want to reset my IoT device like Amazon, Alexa, or Google Nest, so reset or any configuration, that is consumer preferred. But in IoT, it is scheduled and it should be organized. So we cannot able to take a risk on it. So that is a periodic scheduled periodic maintenance has to be done in IoT. Again, because periodic maintenance is there. Other than that, also any fault is going to occur. Also, it will predict. So these are the IoT components which is used for industrial automation. So remote access management of industrial equipments. So any valve, if we have seen some wireless activated valves, pumps, etc., there is no wired connection between this and the devices and the access points. So what does it do is completely get the data, and this data is again given to the any bus, from any bus to Profinet. Based on that, we can able to do the communication. These are the there are a number of components. I have shown some few of the components which is available in the market. In a real world IoT, there are two steps, that is for the factory, for the machines. For the factory, we call it as a smart operations. For the machines, we call it as a smart things. For the factory, system analytics. System analytics means the analysis of the entire manufacturing process has to be done. That is happened through the IoT, and the data sent to the cloud server, and from the cloud we can able to do the various statistical and production statistics which is come under system analytics. and machine health optimizations. So machine health is nothing but for the factory, whether I want to replace this machine or do some any periodic maintenance, it has to be given to the entire list, which are the machines has to be done periodic maintenance, or it is going to get fault, that can be monitored from the for the factory side operations. You see the machines, remote access, remote management, IT integrated service, business intelligence. So remote access is that's what when we integrate some more component into it, we can able to remotely access it. Or I want to calibrate the machine. I don't want to go to the field. Then it can be able to done with the help of remote access. Remote management is, so again it comes under that we can able to manage that entire device from remotely. That we call it as remote. IT integrated services is nothing but we can add intelligence or new algorithms into the machines. So business intelligence, again based on our system analytics, we can able to do much more operations that can be fed to the machines. So this is again IoT enabled machines. This is a manufacturing unit. Any manufacturing unit consists of sensors and actuators, controllers, TLCs or edge devices, and HMIs. So these data are taken there, and output input interface, data aggregation, data contextualization, visualization, remote access, remote management, security, edge computing, cloud connectivity. So these total integrity or integration is done in any process. This is a single unit. This single unit consists of these things, and again a factory consists of n number of these kind of units. So from this cloud, this total machine operation, machine performances, or total the analytics of this machine can be obtained from the cloud, so that from this can be able to compare with other machines. From that we can able to have the total optimization, or total we can able to come to a conclusion that what is that what are the maintenance, or what are the predictions, or what are the things has to be added, or so IIoT applications. The term industrial Internet of Things often occurred in the manufacturing industry, refining industries, to that is oil and gas, and the potential benefit of the industry IoT includes improved productivity and the transformation of the workplace. The potential growth of the implementation of IoT is predicted to generate 15 trillion of global GDP by 2030. This is the prediction, and how when we adapt IIoT or Industry 4.0, definitely the revenue is going to, or the production is going to increase, the revenue is going to increase, and they're much more sophisticated. The producer can produce object based on the demand, which is the market trend. In that way, IoT application can help to an industry. So if you see the manufacturing industry, promotes the computation of the manufacturing industry where the communication and IT system automate production a smart way, creating connected intelligence factories. So here if you see that it is nothing but warehouse automation. In this warehouse automation, how it is done. For example, if you look into Amazon, we think that when we book or when we order a product, a particular product is taken manually. Everything is done manually. It's not the case. Everything is done automatically. When you order the thing, immediately the automation process starts. So that industrial IoT starts from the website of Amazon and to the delivery. So there are numerous processes involved in it: tracking of the product, shipping of the product, and billing of the product, and count of the product, most of the thing. And we do have the entire warehouses automated using robots, or that is not armed robot. It is a moving robot, that is autonomous robot, which is able to deliver from the particular rack, and it can able to ship it. Next one, buildings. We call it as smart buildings. The building management is critical to the performance of any business. For example, the 40% of the energy is consumed by building. The 40% of energy is consumed in buildings, through buildings. That is 26% for heating and cooling. That is for HVAC. So this building automation has to be taken into account to have a good productivity. How we can see that, for example, if HVAC malfunctions or power outage can reduce a small business output significantly, as employees are disgraced grappling with non-work related issues. See, for example, when power goes, when we are working, meantime when power goes, what we do? We do our we don't do into that what work we are looking into it. So when in a factory, if the AC system is not working fine, definitely it leads to a distract. So that has to be taken into account. And next one is the facility that can be detect failures or predict failures, can serve business time and money. So any smart system that is fire, it has to be predict the failures. That means the fire safety alarms. If it should give a notification that it is working fine. If it is not ready, it has to immediately give an alarm that this fire safety alarm is not working. It is not ready to work. In that way, that it has to predict the failures. So connecting the equipment found in buildings such as elevators, HVAC backup power generators, and facility management system is possible in building management. So any building management also come into IIoT, so that we can able to save energy when we use IIoT based on this building automations. Then power and energy. If you see power and energy, smart grid gateways are designed to be used. In 2000, we are just using grids. We are not using any smart grid. Due to the advancement of the smart grid, if you have a solar power, we can directly feed our power to the national power distribution line through smart grids. So solar, wind, traditional produce within high energy consumers. This new IoT gateway allows industrial equipment to communicate with power grids. They are designed for smart grid communication and specifically target demand response. So demand response is to avoid uneven power breakdown. So we need, that is the demand. The power breakdown happens based on the demand. So that to overcome that, when we know the demand, when we have a smart grid, we know the demand, power demand, so that we can able to manufacture power or product power production. We can increase the power production based on, or we can able to switch over the various grid, whichever area there is the power consumption is less, we can able to switch the grid according to that. So this can be done automatically by means of smart grid. That is one of the main advantage. Using advanced metering infrastructure. Advanced meter infrastructure, we are now investing a huge amount of manpower for taking reading and various applications. Every month or a bi-monthly person will come to our home and take reading. So this can be avoided. Smart metering means there is no need for a human interference into it. A meter can directly report the power consumed by a consumer to the power station or electric distribution station, in which not only the power demand, and foreign countries, when we use when we go the power factor less than 1, and definitely if it less than 1 or greater than 1, definitely they will be penalized. So that power factor reading, from that, and the quality of the equipment we are using in the houses, that can be monitored when you use smart metering devices. And another one important thing is water and wastewater treatment. As we all know, global population expands, water becomes more even valuable as a natural resource. It is crucial to communicate more effectively, manage the fresh water to supply a safety process wastewater with financial resources and disposal. So what here you are doing is everything is automized in effluent treatment, so sewage water treatment. So how much amount of sewage water is collected? I think this kind of systems are not so far incorporated in India for commercial purposes. But in factories, we are having wastewater treatment and water treatment for effluent treatment. Sewage treatment from household is done in foreign countries. What they do is they collect all this water. Again, this water is metered. The rate of water is metered, how much wastewater we are sending, and their wastewater is again treated. That is also come into the total industry 4.0. So that this is one of the major application which is the days to come. So this can be most effectively implemented through the use of various wireless and wireless sensor network technologies. Oil and gas industry, as we all know, we are taking pipeline from one source to other. For example, when we are getting oil from oil or natural gas from one particular basin to the refinery, so there will be around 100 and more than 100 kilometers of pipeline. In this pipeline, we must be able to maintain the constant pressure in the pipeline. So every distance, we need to have a monitoring sensor to monitor the pressure or flow. There's some natural the calamities, such kind of thing. So we cannot have a wired structure sensor from each point. So what we are doing is we'll have IoT systems or wireless sensors. So this sensor can directly communicate to the internet. So again, this type of sensor doesn't need any Profinet protocol. So it directly passes the information to the cloud, because it just gives the information 1 second, 2 seconds, because it is not necessary to notice the pressure of the line every millisecond. So every 1 second, 2 seconds gap itself, we can able to monitor the pressure of the pipeline. So in that way, the pipeline can be oil and gas industry pipeline. And other than that, when we are drilling the pipeline, when we are drilling for getting the crude, that we can able to look into the soil profile. Based on the soil profile, we can able to allow that drilling power and the profile of that particular based on the particular profile, the power of that drilling capability can be automized. So that is one thing which is normally used in Middle East for this oil and gas industries. And this is quite interesting. The agriculture industry, most of that is today's many of the students are doing their project in agriculture, but the industry agriculture, that is IoT based agriculture, is IIoT based agriculture is entirely different. That is based on the demand, the farmers can based on the consumer demand, the farmers can grow the crops, and he can able to sell or he can able to fix the price according to the demands or according to the needs. So this kind of application which is used, and even able to diagnose the diseases which is happening into the crops by means of various artificial intelligence techniques. That is, it will feed the data to the cloud, and what type of pesticides which we want to apply for this kind of diseases which is occurred in the particular crops. That can be done, because now what our farmers do, he doesn't know what is some disease has been attacked, and he goes simply and gets some pesticides and just spraying over it. But that is not going to happen near future. And fertilizing and irrigation, and we don't know, we do timely fertilize that, but it is not necessary. Based on the need of the fertile of the soil, we need to do the fertilization. So that what we can do is monitoring this fertilizing and the soil moisture content. These things can be done. So if you see livestock, we use GPS tracking technology for all this livestock, and implant microchip to trace their animals. But we can also pull up various information like the behavior of that animal, the weight, the health, or it has any illness, that kind of thing, whether this livestock can be used for slaughtering, that kind of what is the weight, this kind of things can be used in the agriculture industry. So now we come into the final part, that is advantages of IIoT advantages. While connecting, while connectivity and data acquisition are important for IIoT, they are not the end goals. This is just the beginning. This help of IoT, we can do the predictive maintenance much easier, because predictive maintenance is nothing but that is like forecast. See, how we are forecasting, that is based on that depression, we are saying this that is storm is going to happen in a particular place based on the prediction model. Similarly, we have some prediction things when the vibration sounds goes beyond this, the vibration sound spectrum analysis, that takes to the what is real happen. The bearing of the machine is going to get damaged. So accordingly, we can able to change the bearing. That is done in the predictive maintenance. Intelligent maintenance can reduce unexpected downtime. Unexpected downtime is predictive maintenance can reduce downtime. Even if something goes fault, then we do maintenance. That will lead to shutdown of a particular operation of the plant. So overall maintenance cost up to 30%. That is, there is increase in the revenue, that is 30% increase in the revenue due to the predictive maintenance. Breakdown eliminates breakdown up to 70%. That is according to some literatures. We can able to predict which the machine is going to fall. That is one of the major advantages. So if you see the growth, 60 million machines, factories, 70% greater than 15 years old, 50 billion connected devices in 2020, and 10 to 15 trillion increase of GDP growth in the next 20 years. That is GES predicted. So these are the some of the growth. This is the main thing for the industries. Why and when, whether we can go for IoT or Industry 4.0. So first, we go from the bottom level, societal concern. Societal concern, I think that is not influencing much. Societal concern, that is region-based, whether it is need for the society or not. That is least concern, societal concern. Lack of skilled workforce. That we are, because all the laborers, existing laborers, they are not skilled to adapt this industry 4.0. Privacy concerns is that technology immaturity. Technology immaturity is 20%. It is around 20 to 23%. That's what I am saying, that it is the start. So in another few years, it will come to, it is a growing technology, so we call it as a immaturity. Legacy equipment. Legacy equipment, that is, legacy equipment is, we cannot able to completely modernize the existing old systems. That is one of the major concerns. So when we want to import some of the major equipments, we have to completely replace all these things. So that is one of. So another major concern is uncertain ROI. ROI is nothing but return of income. When I am going to adapt IoT, whether I will get the investment in another 5 years or 10 years, so there is not a certain certainty in the returns. So in this area, most of the industries are concerned whether we will get, because industry mainly they look into profit. So that's why they are looking into the uncertainty in a region of return of investment. Security concern. Security concern is always there in IoT. Normally we say online shopping, we in IoT system, online shopping, all the data has been breached, bank accounts are breached. So these are all very important concern while we import IoT, because it leads to disaster. When somebody breaches a nuclear power plant, then definitely it leads to a disaster. So lack of interoperability or standards. Currently, there are only 2 standards which are existing and which are proved to be performing well. That is, one is Profinet and another one is OPC UA. These are the 2 standards which is available. So all the devices cannot able to communicate with this thing. So we have to, some systems has to be entirely replaced. So that is one of the concern. So in the days to come, there will be new protocols which can able to adapt like IoT. So then it can, this point will be, this will not be a barrier. Industrial. So my time is up, or I can continue another 5 minutes. Can you hear me? Can you hear me?
Can you hear me?
Can I continue for another 5 minutes?
For another 5 minutes?
Okay, sir.
Okay, thank you.
Thank you.
That is, this is one of the major concern, threat and countermeasures. That is, Gartner predicts that 2020 more than 25% of identified attack in enterprise. That is, this is the 10% of IT security budget. So IoT has a potential threat for security breach. So cyber threat are primarily aimed at the industrial control system, that is ICS, such as distributed control system, programmable logical controllers, SCADA, and HMIs. The adoption of IP-based connectivity users communicate between multiple industrial devices has increased security risk. So because it is similar to like hacking a system. So to have a growth of sophisticated smart system, this make industrial control system most vulnerable target in the industrial world. This is one of the major concern. So if you see that this is a major threat in IIoT, the device hijacking, so terminal denial of service, and denial of service, man in the middle. These are the three areas. So this is the man in the middle. The man in the middle is nothing but somebody is gaining the control of a robot manipulator. We have seen many Hollywood movies. Somebody is getting a robot control from the remote and he can able to destroy the entire factory. So similarly, that kind of security breach is happening. So device hijacking the device, even you can able to hijack a plane, or we can you can able to make malfunction of the flight control system. So these kind of attacks are aimed at IoT infrastructure in cloud. So man in the middle, an attacker breaches, interrupt, or spoofs communication between the two systems. And IoT scenario, it could assume the control of a smart actuator and knock at the industrial robot and designated lane, speed limit, potentially damage assembly line or injuring operators. So this is one of the things that then device hijacking, the attacker hijack the efficiently assume the control device. These attacks are quite difficult to detect because of the attacker. So when we hijack, it is very difficult who is doing this. When somebody hijack our particular device. So in all IoT scenario, hijacker could assume the control of smart meter and user. That is, when you use a smart energy meter and energy management system, he directly hijack this energy management system, and he can able to do the mismanagement system there, and he can able to shut down the power lines. He can able to do malfunction on the power lines and change the power schedules, etc., etc. This is one of the this we call it as a device hijack. Distributed denial of service. That is a denial of service attack. Attempt to render a machine or network. So okay, in that DDS, we call it as a distributed denial of services. So in wide range of IoT applications, it causes serious disruption of utility services and manufacturing facilities. So when a device is not working, so definitely the production line is affected, and we need to do a countermeasure for that. So either we have to do the maintenance work for that, and we have to replace a particular chip or something like that. And permanent denial of service is one of the major thing. It also known as the flashing in an attack that damages the device so badly. So it will entirely wipe up the ROM of the device. So we just need to reinstall the hardware. So that is one of the major setback in IIoT. So securing the industrial, this is the final slide. Securing the industrial IoT is there are various ways. Firmware integrity and a secure boot. When we start a system, we are having a secure boot. That is, today's devices are coming with secure boot, and existing devices are not having a secure boot. Mutual authentication. Mutual authentication is nothing but we need to give a key to who is going to access the particular machine. So mutual authentication, when we are to integrate a particular machine to a machine, then we need to give a authentication. That is a mutual authentication. Secure communication, that is end-to-end encryption. So either elliptical encryption, or there are various types of encryption, cryptographic encryptions are there. So similar kind of encryption that can be able to secure the IoT. And security monitoring analysis. Somebody breaches or anyone hacking the system, that should be notified. That will be called as a watchdog, security watchdog. And security lifecycle management. Security lifecycle management, that is also, we need to do the management of the security of the system is working. That also to be noticed. Other than that, the hardware system is called digital diodes. Digital diodes, what it does is it allows only one-way data to the end users. But when we use a particular key only, they can able to pass the data from the other end. So when we use digital data, it is similar kind of digital diode. It is similar kind of our electron diode. So it passes power from one direction. Similarly, it passes data to one direction. So that kind of system can be incorporated. So these are the references, which is taken from various sources. Thank you. If you have any questions, you can ask.
Participants, if you have any queries regarding the industrial IoT, with the contents we have discussed in the session, you can kindly ask me. Sir, excuse me, sir.
Hello.
Yeah, yes, sir. So
Yeah.
actually, sir, now we are discussing with industrial IoT, right, sir? So far we have discussed that, but and also we have discussed some barriers about implementation of industrial IoT.
Yeah.
Okay. Yeah. So, how much time it will take for a huge country like India to offer a full automation of industry?
I think in India there are only few that is like Amazon, that is like online. This they have come into that industrial IoT, and 100% so far we are not completely. We are just a developing country. Now only we are getting a high-speed internet. So I think in another 5 years it takes. For 100% it is not sure. Another 5 years to at least 25% of our companies to follow IoT. Another 5 years it will take.
Okay, sir. Actually, sir, now on the scheme of Digital India, many startups were coming up to incorporate this digital world, taking towards IoT. So now we are also in the situation of COVID, that is some virtual reality, all the things. It's hoping up. So we think we'll see the near future.
Okay. Yeah, actually, these startups we don't mix with these startups. They deal with IoT, but industrial IoT is entirely different. It starts from the floor to the top level. So the total factory is completely done with the standards. So that way, that there is a lot of investment involved in it. Actually, the investment is much higher, not like developing a new plant or something like that. So we have to 50% of the component has to be replaced.
Yes, sir.
So
Actually, some multinational corporations like maybe like General Electrics, Alton, sorry, investing in SCADA, right, sir? Actually, they were
SCADA is already there, which is during 1980s. SCADAs are there. When DCS PLC is there, SCADA is there. But SCADA works previously. It is working under this Profibus.
yeah.
Now we are working SCADA with OPC UA.
Yeah, yes.
So that is the leverage now we got. Now SCADA is working under cloud. Previously it was working under standalone.
Standalone mode, yeah.
Yeah. So now that is the advancement. So the thing is going to evolve. Now only we have started because OPC UA has evolved in 2008. We have studied Wi-Fi in late 1980 something at that time itself. But now the application is coming now only. We have not ever received Wi-Fi internet in our state. So for only in cities we are having Wi-Fi internet. Wi-Fi service providers.
Yes. So maybe in the near future we'll have robo near to us.
Yes.
Participants, any other queries on the side? But whether it will create an employment, sir, industrial automation will create skilled employment.
Yeah, one literature shows that instead of giving training to the existing employers, it is better to hire a new employees.
That is an industrial ethics that is following now. But actually, so now the question is now all over, not only in India, all over the country, we are facing some, not only before COVID, actually, not only now in COVID, before COVID is World Bank is saying we are in economical crisis and all. Actually, it is because of inflation and many factors. But
Yes.
most of the literature survey they were mentioning like it's all because of automation.
Yeah, of course. Yeah. Definitely, there is after the introduce of this online shopping, the small vendors has vanished now.
But on the other side, some are saying it is like jobs were there, some skilled laborers were on demand. Likewise, also some were claiming. So how to justify some employment is there?
The invention of after the invention of robotics in manufacturing industry, there is around 75% of the job has reduced. Human jobs are reduced. And definitely automation makes jobless. That is, it is when we, yes, of course. When we go into technology, we need, but there are jobs for developing some new skills which is required for this one. There is subset that there are some startups, they develop some algorithms which suits for this standards, or they can find some new devices. That kind of things we can able to develop. That kind of things, there are openings are there.
Actually, openings are there, but the forms of opening is different.
Yeah, in previous yeah, if I want if I were if I'm sorry, recruitment is taking in a company, I need 100 engineers. Now I need 10 to 15 engineers. That is more than enough if I have a sophisticated machines.
So, according to your view, after 10 to 15 years, unemployment in India will rise?
Not only in India, not
all
only
over the world.
all over the world. So only thing is agriculture. We have to focus on agriculture.
Yes, actually, we are moving back to that Stone Age.
Yeah, the smart Stone Age. Smart Stone Age. That's what we call it.
Yeah. Yes. Participants, any other queries? I think we have no more questions, sir.
Okay.
So, yeah, shall we wind up now, sir?
Yeah. Thank you.
Sir, thank you, Dr. P.S. Godwin, Anand, sir. In spite of his busy schedule, accepting our invitation and delivering an expert lecture in IoT, especially in the field of industrial automation. Thank you once again, sir.
Okay, thank you.
Participants, you can fill your attendance link